We've talked already about the difference between the cueing systems approach to learning to read or teaching children to learn to read and the processing models. So what we want to talk about now is sort of explaining the processing model that was developed initially by researchers such as Marilyn Adams in the 1990s. 1990s. The graphic that I've provided for you is from her book, Beginning to Read, that was published in 1990. It really changed the way we think about teaching children to read. And what I want to talk about is sort of explaining that model to you a little bit and how it affects how we teach children in the earliest grades to read. First of all, if you'll look at the model, you'll notice that there are arrows that go back and forth between the different components. And literally that's what's going on in the brain. So much of what we do when we read is interactive. So let's talk a little bit about each of these components. First of all, the orthographic processor is literally what happens is the processor that takes in print in a visual form. So a child looks at a word, for example, and that word then is translated by the brain through the orthographic processor. On the other hand, a phonological processor is activated initially through the spoken word. So the two work together simultaneously, and all of this is going on sort of automatically within the brain. When a child first looks at a word on a printed page, the brain goes into, takes that information into the orthographic processor. It has two automatic decisions to make. The brain can then either activate the phonological processor or it can activate the meaning processor. So how does that, the brain make that decision? And remember, this is all sort of an automatic thing that goes on. First of all, if the word is new to the child, if they've never seen this word before, automatically the brain's going to send that visual message to the phonological processor. And what happens in the phonological processor is that the child then attempts to decode the word based on what they know about phonemic awareness and the alphabetic principle. If, on the other hand, the child has encountered that word successfully, remember, decoding it automatically, decoding it accurately about 6 times, generally will store that word into their lexicon. Then if that child, if this is not a new word to the child, then the brain automatically sends it to the meaning processor. Let's review just a second what we've learned about the brain and how it processes words in language. Remember that the parietal temporal region of the brain is where the actual decoding takes place. And again, after a typical child encounters a word 6 to 10 times accurately, that word is then stored, and it's stored in the occipital temporal region of the brain. If that word has been stored in the occipital temporal region of the brain, then of course the brain can send it to the meaning processor. Now, one thing I want to point out is that just because a word is stored in the occipital temporal region doesn't necessarily mean that the child knows that word as part of their vocabulary of meaning. We have to be cautious when we think about the processing model. If we push fluency too much, if that is the main emphasis of reading instruction, is to have a child processing words faster and faster and faster and building up fluency rates, we have to be careful not to make that leap to say that because they read fast that they read with good comprehension. We know that's not necessarily true. More and more I see children who are reading fast but not really understanding what they what they're reading. So we have to be careful when we make, when we use this processor to say automatic decoding or automatic word reading necessarily causes comprehension to rise. Okay, so the orthographic processor then again is based on visual input. The child reads the word off the page, and then the word then therefore goes through the orthographic processor, and the brain will automatically either send it to the meaning processor or send it over to the phonological processor. On the other hand, if a child hears a spoken word, speech, that word then is fed first through the phonological processor. What happens to it at that point, the decision that the brain makes, is based on the purpose of hearing that sound, the speech, the words. If, for example, in a classroom, you're reading aloud to a child, the word goes into the phonological processor and then automatically goes to the meaning processor. That's why reading aloud to children is so very important, because it develops comprehension skills without the child actually having to, the child's brain actually having to make that decision to whether it goes to the orthographic processor or goes to the meaning processor. When you read aloud, it goes from the phonological processor to the meaning processor automatically. If, on the other hand, you are saying a word and you want that child to spell the word, then that word is going to go to the orthographic processor. That's why we advocate using spelling inventories to determine the level of skill that a child has with phonemic awareness and phonics. Can they encode that word accurately to write it down so that it's spelled correctly? So we can use how they're spelling the words that we say out loud to them to determine how accurately they can implement the alphabetic code to write words accurately. Now, the meaning processor is just what it says. Meaning is, of course, the whole point of reading and of all literacy activities. And so, therefore, you can see how we have to, when we look at this, the processing model, all of these things are interconnected. So even when you're speaking, it goes to the meaning processor, and then you see the other part of the processing model that Adams developed is the context processor. What's the role of the context processor? Well, often some words have multiple meanings, and so you have to, again, that's where the context clues come into play when we're talking about decoding words or getting the meaning accurately. Light can mean different things. It can mean the light in the sky, or how bright the room is, or it can mean weight. And so the child has to look at the context clues to determine what the meaning of the word is. So you see how those can go back and forth also. So this is a little discussion about the processing model. We'll talk more about it later, but this is so important to understanding how the brain actually helps, how the brain works in teaching a child how to read.